Now that we know what an algebraic expression is, I want to spend some time simplifying algebraic expressions, and then Steve is going to evaluate some algebraic expressions. Specifically, I'm first going to review the distributive property, and then use the distributive property to simplify algebraic expressions. So let's start by reviewing the distributive property. If a, b, and c represent real numbers or algebraic expressions, then a times the quantity b plus c equals ab plus ac. We say that multiplication distributes over addition. I want to start by looking at some geometric interpretations. So I'm starting with a square which has a length of 1 and a width of 1. 1 times 1 is 1, so the area of the square, length times width, is 1. If I put two of these squares side by side, I've created a rectangle which has a length of 2 and a width of 1. So the area of this rectangle is 2 times 1, which is 2. Now if I want a rectangle that has area x, I need to start with a rectangle that has a length of x, where x is positive since it's representing a length, and a width of 1. Now, length times width, x times 1, gives me an area of x. So I want to use this idea with the distributive property. So I want to distribute 3 over the quantity x plus 2 using this geometric interpretation. So I'm going to start out with my rectangle representing x. I'm choosing this because it has a length of x. Inside my parentheses, I have x plus 2. So I actually want a length of x plus 2. To get that, I'm going to take 2 of the 1 by 1 squares. So now I have, looking at this entire rectangle in both colors, a length of x plus 2. I need 3 of these because I'm taking 3 times the quantity x plus 2. So there's 1, 2, and 3 of these. Now if I look at this large rectangle has a length of x plus 2 and a width of 3. So the area of this rectangle is 3 times the quantity x plus 2. That's exactly what I'm trying to find here. I want to look at this rectangle in two parts. I want to start by looking at the left-hand side. Now looking at the left-hand side, we see a rectangle which has a width of 3 and a length of x. So the area of this rectangle is 3 times x, which is 3x. Looking at the right-hand side, I have a rectangle which has a width of 2 and a length of 3. So the area, width times length, is 2 times 3. Well, this is just showing the distributive property. 3 times the quantity x plus 2, according to the distributive property, I need to distribute the 3 to both the x and the 2. That's 3 times x plus 3 times 2. So looking at our rectangle in two different ways, we started out by looking at the large rectangle, noting that it had a width of 3 and a length of x plus 2, and then we looked at the two parts of this rectangle. The left-hand part, we had a rectangle of area 3x, and the right-hand part, we had a rectangle of area 3 times 2. And we can simplify this expression as 3x plus 6. Well, now let's just look at the distributive property alone without the geometric interpretation. Let's say I want to distribute 7 over the quantity 2y plus 3. So according to the distributive property, I need to distribute the 7 to the 2y, and I need to distribute the 7 to the 3. So I'd have 7 times 2y plus 7 times 3. Now 7 times 2 is 14, so my first term is 14y plus 7 times 3 is 21. Now we already mentioned that multiplication distributes over addition. Well, we also know that multiplication distributes over subtraction. Let's look at an example. Let's say I wanted to find 4 times the quantity 3a minus 5. The distributive property tells me I need to distribute the 4 to the 3a, and I need to distribute the 4 to the 5. So I have 4 times 3a minus 4 times 5. 4 times 3 is 12, so my first term is 12a minus 4 times 5 is 20. What if I want to find 2 times the quantity 3x minus 4y plus z. Crossing my z here so that it doesn't look like my 2. Well, now I need to distribute the 2 to all 3 of the terms in the parentheses. So I would have 2 times 3x minus 2 times 4y plus 2 times z. 2 times 3 is 6, so my first term is 6x. 2 times 4 is 8, so my second term is minus 8y. And 2 times z we can just write as 2z without the multiplication symbol. So that's plus 2z. Now we just saw multiplication distributing over 3 terms in parentheses. Multiplication actually distributes over 3 or more terms in parentheses. Wouldn't matter if I had 5, 10, 100 terms in the parentheses. I could still distribute my multiplication over each of those terms. Now let's look at the quantity 5x minus 6y multiplied by 4. Now we know in the distributive property it doesn't matter what side our subtraction occurs on and what side our factor 4, in this case, occurs on. The distributive property still works. To remember why it still works, we can actually apply the commutative property of multiplication. So I can rewrite this problem as 4 times the quantity 5x minus 6y. It's not a necessary step, not something that you have to write down if you don't want to, but I just wanted to remind you why the distributive property works, no matter what side our factor 4, in this case, sits on. So now I need to distribute the 4 to each of the terms in the parentheses. So I have 4 times 5x minus 4 times 6y. 4 times 5 is 20, so my first term is 20x, minus 4 times 6 is 24, so my second term is minus 24y. What about r minus 8 times 1/4? This time I'm just going to do the commutative property of multiplication in my head. I know I need to distribute the 1/4 to both the r and to the 8. So I have 1/4 times r minus 1/4 times 8. 1/4 times r we can simply write as 1/4 r. We can also write that as r over 4. 1/4 r is equal to r over 4. 1/4 times 8 is 8/4, and 8 divided by 4 is 2. So my second term is minus 2. Let's try 1/3 times the quantity 3x plus 6. Now I need to distribute the 1/3 to each of the terms in parentheses. So I have 1/3 times 3x plus 1/3 times 6. 1/3 and 3 are multiplicative inverses. When we multiply multiplicative inverses together, we get the multiplicative identity, which is 1. So 1/3 times 3 is 1. So my first term is 1x. 1/3 times 6 is 6/3. 6 divided by 3 is 2. So I have 2 as my second term. Now we generally don't write a coefficient of 1. 1 times x is just x. So in simplified form, I would write this as just x plus 2. Now let's try negative 2 times the quantity 3k plus 4. So I need to distribute the negative 2 through to each of the terms in parentheses. So I have negative 2 times 3k plus negative 2 times 4. Negative 2 times 3 is negative 6, so my first term is negative 6k. Negative 2 times 4 is negative 8, so I have plus negative 8. Now I can rewrite this addition expression as a subtraction expression. I can rewrite this as negative 6k minus 8. Subtracting 8 is the same as adding negative 8. Now let's try negative 2 times the quantity 3k minus 4. I need to distribute the negative 2 to both of the terms in parentheses. So I have negative 2 times 3k minus negative 2 times 4. Negative 2 times 3 is negative 6, so my first term is negative 6k. Negative 2 times 4 is negative 8, so I'm subtracting negative 8. I can change this subtraction expression into an addition expression, negative 6k plus 8. Subtracting negative 8 is the same as adding the opposite of negative 8, and the opposite of negative 8 is positive 8. What about negative 2 times the quantity negative 3k minus 4? I need to distribute the negative 2 through the parentheses. So I have negative 2 times negative 3k minus negative 2 times 4. Negative 2 times negative 3 is positive 6, so my first term is positive 6k. Minus negative 2 times 4 is negative 8. I can rewrite this subtraction expression as an addition expression as 6k plus 8. Subtracting negative 8 is the same as adding 8. Now let's try the opposite of the quantity 4m minus 7. To see what we're doing, I'm going to rewrite this problem a little bit as negative 1 times the quantity 4m minus 7. So the distributive property tells me I need to distribute the negative 1 to each of the terms in parentheses. So I have negative 1 times 4m minus negative 1 times 7. Negative 1 times 4 is negative 4, so my first term is negative 4m minus negative 1 times 7 is negative 7. And I can rewrite this as negative 4m plus 7. Now something I want to point out here is what we've essentially done with this original problem is distribute the negative through the parentheses. In the original problem, inside the parentheses, I had positive 4m minus 7. After I distributed the negative through the parentheses, I ended up with negative 4m plus 7. So a shortcut for distributing a negative through parentheses is to change the sign of each of the terms in parentheses. In this case, our 4m became negative 4m, and our minus 7 became plus 7. So let's try another one. How about the opposite of negative 4m minus 7? Again, if I want to, I can think of this as negative 1 times the quantity negative 4m minus 7. What I expect to happen here is for the sign of each of the terms in the parentheses to change. So let's go through, use the distributive property to distribute the negative 1, and see if the signs of the terms inside the parentheses change. So I have negative 1 times negative 4m minus negative 1 times 7. Negative 1 times negative 4 is positive 4, so my first term is 4m minus negative 1 times 7 is negative 7. But this is the same as 4m plus 7. Let's check for the sign changes. We were distributing the negative through the parentheses. Inside parentheses, I started with negative 4m minus 7. After distributing, I ended up with positive 4m plus 7. So indeed, the sign of each term inside the parentheses did change. Well, now let's try simplifying 4m minus the quantity negative 4m minus 7. I'm going to start by rewriting this subtraction expression as an addition expression, as 4m plus negative 1 times the quantity negative 4m minus 7. So I can see that I need to distribute the negative 1 through this second set of parentheses. So I have 4m plus negative 1 times negative 4m minus negative 1 times 7. So I have 4m plus negative 1 times negative 4m is positive 4m, minus negative 1 times 7 is negative 7. Well, 4m and 4m are like terms. I can go ahead and combine those. 4m plus 4m is 8m, and subtracting negative 7 is the same as adding 7. So this simplifies to 8m plus 7. Before I move on, I want to point something out here. I had the subtraction symbol in front of the parentheses in my original problem. Let's look to the point where I have distributed the negative through the parentheses. So I rewrote the problem, I applied the distributive property, and I got a positive 4m, which has opposite sign. I started with negative 4m. I also got minus negative 7, which is the same as plus 7. Again, the sign changed. I started out with minus 7. I ended up with plus 7. So even though this is a subtraction problem, again, what we essentially did was distribute a negative through parentheses. Now let's try a problem with fractions. I have 2/5 times the quantity 5/2 x plus 1/2. I need to distribute the 2/5 through the parentheses. So I would have 2/5 times 5/2 x plus 2/5 times 1/2. 2/5 and 5/2 are multiplicative inverses. When I multiply multiplicative inverses together, I get the multiplicative identity 1. So my first term is 1x, which I just write as x. 1 times x is x. For my second term, I'm multiplying 2/5 by 1/2. I can pull out a factor of 2 in the numerator and denominator. 2 divided by 2 is 1, so I'm left with 1 in the numerator, 5 in the denominator. So this simplifies to x plus 1/5. Now I want to look at simplifying some more complicated algebraic expressions. I want to start with a definition of simplifying an algebraic expression. An algebraic expression is simplified when all parentheses have been removed and all like terms have been combined. A term is simplified when all numerical factors have been multiplied and written as a coefficient of the variable factors. The variable factors should be written in alphabetical order. So for instance, 3y times 2x is not simplified. To simplify 3y times 2x, I need to multiply the 3 and 2 together, which gives me 6. And then looking at my variable factors, I have a y and an x. And our definition here says the variable factors should be written in alphabetical order. So I'll write this as 6xy. My numerical factors have been multiplied, written as the coefficient 6, and my variable factors x and y are written in alphabetical order. Let's try simplifying 3 times the quantity 5p minus 4 minus 7p. I needed to start by distributing the 3 through the parentheses. I'm going to do some multiplication in my head here. I know I need to multiply 3 times 5p, so I'll multiply the 3 and 5 together. That gives me 15. So my first term is 15p. Then I know I need to subtract what I get when I multiply 3 and 4 together. 3 times 4 is 12. So my next term is minus 12. And then I have this minus 7p at the end. Now I need to look for like terms. 15p and negative 7p are like terms. When I add 15p and negative 7p, I get 8p. So this simplifies to 8p minus 12. What about 9 times the quantity 3a plus 2b plus 5 times the quantity 2a minus 3b? Now I need to distribute the 9 through the first set of parentheses and the 5 through the second set of parentheses. Again, I'm going to do the multiplication in my head. 9 times 3 is 27. so my first term is 27a. 9 times 2 is 18, so I have plus 18b. Moving on to the second set of parentheses, 5 times 2 is 10, so I have plus 10a. And 5 times 3 is 15, so I have minus 15b. Now looking for my like terms, 27a and 10a are like terms. 27a plus 10a is 37a. 18b and negative 15b are like terms. 18b plus negative 15b is 3b, so I have plus 3b. Now let's try 2 times the quantity 7 minus 8a plus 3 minus 5a in parentheses. I'm going to distribute the 2 through the first set of parentheses. 2 times 7 is 14, minus 2 times 8 is 16, so I have 16a. Now I just have an addition symbol in front of the second set of parentheses. I can think of this as plus 1 times the quantity 3 minus 5a, but multiplying 1, our multiplicative identity, by an expression doesn't change the expression. So I can take this out of parentheses just as 3 minus 5a. That second set of parentheses wasn't really necessary. Distributing an addition symbol, or a plus, through the parentheses doesn't change anything. Whereas if this had been a subtraction symbol and we wanted to distribute it through the parentheses, we would have had to have changed the signs of the terms. Now let's look for like terms. Our constants, 14 and 3, can be added together. That gives me 17. And then I have negative 16a and negative 5a. Those are also like terms. When I add negative 16a plus negative 5a, I get negative 21a. So I have 17 minus 21a. Now let's try 3 times the quantity 4m minus 5 minus the quantity 10m plus 2. I'm going to distribute the 3 through the first set of parentheses. And remember, I can think of this as plus negative 1 times 10n plus 2. Distributing the negative 1 through the second set of parentheses should change the sign of each of the terms in the second set of parentheses. Let's worry about that when we get there. Let's start with the first set of parentheses. 3 times 4m, I can multiply 3 and 4 in my head. That gives me 12, so my first term is 12m. 3 times 5 is 15, so I need to subtract 15 here. Now I'm going to distribute that negative through the parentheses, remembering that what that does is changes the sign of each of the terms in the parentheses. So this becomes minus 10m minus 2. Now I have some like terms. 12m and negative 10m are like terms. 12m plus negative 10m is 2m. I can also combine my constants. Negative 15 plus negative 2 is negative 17. So I have 2m minus 17. Now let's try 2 times the quantity 4x plus 1 minus 3 times the quantity x minus 4. Before I do anything on this problem, I'm going to rewrite this as an addition problem. Instead of subtracting 3 times the quantity x minus 4, I'm going to add negative 3 times the quantity x minus 4. So I'm going to rewrite this as 2 times the quantity 4x plus 1 plus negative 3 times the quantity x minus 4. This is a step I usually do in my head. If it helps, make sure you do write this step out. But if you can do this in your head, that's fine as well. I tend to think of everything in terms of addition. When I have a subtraction problem, I know that I can always rewrite it as an addition problem. So when I see this subtract 3 here, in my head I'm thinking plus negative 3, which is exactly what we wrote over here. The reason I rewrote it is so that I can distribute the 2 through the first set of parentheses and distribute the negative 3 through the second set of parentheses. 2 times 4x is 8x, plus 2 times 1 is 2. Then I'm adding negative 3 times x. Negative 3 times x is negative 3x. Now at this point, I could have just written minus 3x. I know that adding negative 3x is the same as subtracting 3x. Then I'm adding negative 3 times negative 4. Again, I'm thinking of this as an addition problem. X plus negative 4. Negative 3 times negative 4 is positive 12. Looking for my like terms, 8x and negative 3x are like terms. 8x plus negative 3x is 5x. 2 plus 12 is 14. So I have plus 14 as my constant. Now let's try a problem with nested grouping symbols. Here I have 2 times the quantity 3a plus 5 times the quantity a minus 1. Remember, with nested grouping symbols, we need to start with our innermost set of grouping symbols. That's the parentheses around the a minus 1. A and negative 1 aren't like terms. I can't do anything with that, but I can distribute the 5 through that set of parentheses. So I have 2 times the quantity 3a plus 5 times a I can write as 5a minus 5 times 1 is 5. Now looking inside my grouping symbols, I have like terms. 3a and 5a are like terms. When I add 3a and 5a, I get 8a. So I have 8a minus 5 in my grouping symbols. Finally, I need to distribute the 2 through these grouping symbols. 2 times 8a is 16a, minus 2 times 5 is 10. I could have also thought of that as plus negative 5, so I could have thought of adding 2 times negative 5, but 2 times negative 5 is negative 10. Adding negative 10 is the same as subtracting 10. Just two different ways of looking at the same problem. Here's another problem with nested grouping symbols. 3 times the quantity 2t minus the quantity t plus 4. This time, looking at my innermost set of grouping symbols, the first thing I'm going to need to do is distribute the negative through the parentheses. So I have 3 times 2t minus t minus 4. Inside my grouping symbols, 2t and negative t are like terms. 2t plus negative t is 1t, which I can write as just t. So I have t minus 4 in my grouping symbols. Distributing the 3, I would have 3t minus 3 times 4 is 12. Now let's try 3 plus 5 times the quantity 2x minus 3 times the quantity x plus 4. The first thing my eyes are drawn to on this problem are the 3 and the plus 5, that addition up front. But I need to remember the order of operations tells me that addition and subtraction come last in the order of operations. So it's going to be a long time before I can add the 3 to whatever I have left here. I need to start inside my grouping symbols and start with my innermost grouping symbols. In this case, I'm going to look at this as 2x plus negative 3 times the quantity x plus 4. So I'm going to distribute the negative 3 through the parentheses around the x plus 4. So I have 3 plus 5 times the quantity 2x plus negative 3 times x is negative 3x. Adding negative 3x is the same as subtracting 3x. So I'm just going to write this down as minus 3x. Plus negative 3 times 4. Negative 3 times 4 is negative 12. Adding negative 12 is the same as subtracting 12. So I'm just going to write down minus 12. Inside my grouping symbols, I have like terms, 2x and negative 3x. When I add 2x and negative 3x, I get negative 1x, which I can write as just the opposite of x. So I have the opposite of x and minus 12 as my other term. In my grouping symbols, I'm left with the opposite of x, minus 12. I still can't add the 3 and 5 together. I need to distribute the 5 through the grouping symbols. So I have 3 plus 5 times negative x. 5 times negative x, or 5 times the opposite of x, is negative 5x. adding negative 5x is the same as subtracting 5x. So that's how I'm going to write it down. Then I can think of this as plus negative 12. So I have 5 times negative 12 is negative 60. Adding negative 60 is the same as subtracting 60. So I'll write that last term down, negative 60. Now my constants, 3 and negative 60, are like terms. I can go ahead and combine those. 3 minus 60 is negative 57. So I have negative 57 minus 5x. Now if you went through and simplified a problem like this, and you went to check your answer in the back of the book, and the back of the book said negative 5x minus 57, your simplification would not be incorrect. All that you have to think about here to see why these last two expressions are equal is the commutative property of addition. If I think of the expression negative 57 minus 5x as the addition expression, negative 57 plus negative 5x, I know I can add in any order and change this to negative 5x minus 57. Now let's try 7 minus 3 times the quantity AB minus B times the quantity 2A plus 3. Again, my eyes are drawn to what I see first there, the 7 minus 3. Addition and subtraction come last in the order of operations, so I can't start there. I need to start with my grouping symbols. And in fact, I have nested grouping symbols. I need to start with the innermost grouping symbols. 2A plus 3, I can't do anything with that. They're not like terms. What I'm going to do is distribute negative b through those parentheses. So I have 7 minus 3 times the quantity AB plus negative b times 2a, I can write as negative 2ab, writing my coefficient 2 in front, and my variables a, b in alphabetical order. Adding negative 2ab is the same as subtracting 2ab. Then I have negative b times 3. I can write that as negative 3b. Adding negative 3b is the same as subtracting 3b. Looking at my grouping symbols, AB and negative 2AB are like terms. So I'm going to combine my like terms, remembering AB has a coefficient of 1, so I need to subtract 1 minus 2. 1 minus 2 is negative 1. So I have negative 1AB, which I can write as negative AB, minus 3B. I still can't do the subtraction. Instead, I need to distribute the negative 3 through parentheses, thinking of this as 7 plus negative 3. So I have 7 plus negative 3 times negative AB is positive 3AB, and negative 3 times negative 3B is positive 9B. Now looking at my expression, I don't have any like terms. If I were to compare my answer to the answer in the back of the book, the terms might be written in a different order, but the two expressions would be equivalent. So 7 plus 3AB plus 9B, for instance, is the same as 3AB plus 9B plus 7. The commutative property of addition tells me I can write my terms in any order. Now I'm going to turn this over to Steve, who's going to talk about evaluating algebraic expressions.
Hello. Today I'm going to talk about evaluating algebraic expressions. When we use the phrase evaluating algebraic expressions, what we typically mean is that we are going to take an algebraic expression, we are going to replace the variable or variables in the expression with a number or numbers, and we're going to see what the resulting value is for the algebraic expression. Let's begin with the example, evaluate 3x for x equals 2 and x equals negative 2. What people will casually say sometimes is that we need to write down, for example, 2 rather than x, or negative 2 rather than x. But it's a little more complicated than that, because if I take this expression 3x and I just write down 2 instead of x, I have the number 32. And similarly, if I take the expression 3x and I just write down -2 instead of x, I have the expression 3 minus 2. Neither of these accurately reflect the meaning of 3x. Remember, when we write down 3 followed by an x, there's an implied multiplication occurring between the 3 and the x. 3x is short for 3 times x. So when I replace x with 2, I need to make sure that I clearly indicate that the operation that's occurring between 3 and 2 is multiplication. And one way that I can do that is I can write the 2 inside of parentheses. So when I evaluate the expression 3x for x equals 2, I need to make sure that I write the 2 either inside parentheses or I write a dot between the 3 and the 2. I also need to indicate that I am going to make this replacement, or sometimes we use the word substitution, of 2 for x. And I can do that by writing before this algebra the phrase, if x equals 2, then the expression 3x, which is short for 3 times x, equals 3 times 2, which in turn is 6. If x equals 2, the value of the expression 3x is 6. I have evaluated the expression 3x when x equals 2. If x equals -2, then our expression 3x, which is short for 3 times x, is equal to 3 times -2, which is -6. Let's see another example. Let's evaluate the expression 3 minus x for x equals 2 and x equals -2. If x equals 2, then the expression 3 minus x equals 3 minus 2. Notice this time I did not write the 2 in parentheses. That's because I didn't need any sort of parentheses to clearly communicate the operation that needs to be performed. I need to subtract x from 3. I need to subtract 2 from 3. That is clearly communicated simply by writing down 3 minus 2. And 3 minus 2 is 1. On the other hand, if x is -2, then the expression 3 minus x is 3 minus -2. It's customary when subtracting a negative number to write the number inside parentheses. So this time, I am going to put parentheses around the -2. When you're deciding, should you use parentheses or is it okay not to use parentheses, you just have to think about how you would write the arithmetic no matter what context the arithmetic was occurring. When I subtract a negative, the number goes in parentheses. That's why I have negative, or parentheses, around the -2. Subtracting -2 is the same as adding +2, and 3 plus 2 is 5. So if x equals -2, the expression 3 minus x evaluates to 5. Let's evaluate x squared and opposite x squared for x equals 5. If x equals 5, then the expression x squared is equivalent to or equals the number 5 squared. I don't need parentheses because 5 squared clearly communicates that I need to square 5. The square of 5 is 5 times 5, which is 25. If x equals 5, then the expression opposite x squared equals the opposite of 5 squared. Now things get a little bit sticky here because a lot of people, and you very well may be one of these people, when they see this set of symbols right here, a minus sign followed by a 5 squared, what they think this means is negative 5 times negative 5. That's a very, very natural thought to have. But we don't get to decide the meaning of the symbols for ourselves. Somebody's already made that decision for us. And the meaning of the symbols, a negative sign followed by a 5 with an exponent of 2, is it's the opposite of 5 squared. And a way you can help yourself remember that is you can remember that taking the opposite of a number is the same as multiplying the number by negative 1. So I can think of this as negative 1 times 5 squared, and I know because of order of operation that the first thing I need to do is square the 5. When I square 5, I get positive 25, but that positive 25 still needs to be multiplied by negative 1. Negative 1 times positive 25 is negative 25. If x equals 5, the value of the opposite of x squared is the number negative 25. Let's evaluate x squared for x equals negative 5. If x equals negative 5, then the expression x squared equals the number negative 5 squared. Now let me show you something I've seen people write before. They'll write this down. They'll write the number negative 5, they'll put an exponent 2, and then they'll say the net result is 25. This is only half correct. It's true that when x equals negative 5, the expression x squared does evaluate to positive 25. But what's written down in the middle here is not correct, because we saw in the last example that when you write down the symbols opposite 5 squared, the result is negative 25. And it just cannot be the case that in some cases the symbols opposite 5 squared means negative 25, and in other cases the symbols opposite 5 squared equals positive 25. So what we're going to do here is we're going to write the negative 5 inside parentheses, because now we have correctly indicated that the number that's being squared is negative 5. And negative 5 times negative 5 is a positive number, because when you multiply together two negative numbers, the result is positive. In this case, positive 25. Let's evaluate the expression t minus t squared for t equals negative 3. If t equals negative 3, then our expression t minus t squared is going to be the number negative 3 minus the result of squaring negative 3. When I subtract a number from negative 3, there's no need to write the negative 3 inside parentheses. On the other hand, as I just discussed, when you're squaring a negative number, you always have to write the negative number inside of grouping symbols. So I'm going to use parentheses, and I'm going to write the negative 3 inside parentheses. And the negative 3 is the number that needs to be squared. There's two terms in this expression, and ultimately the operation I'm performing is subtraction. The second term is being squared. So I need to, because of order of operation, perform the power before the subtraction. When I square negative 3 times negative 3, the result is positive 9. And if I subtract 9 from negative 3, the net result is negative 12. So if t is negative 3, the value of the expression t minus t squared is negative 12. I have evaluated t minus t squared when t is negative 3. This one's a little complicated. Let's work through it. Let's evaluate the fraction 2y minus 3y squared over y squared minus 20 for y equals negative 5. If y equals negative 5, then our expression 2y minus 3y squared over y squared minus 20 equals, first thing I need to do is I need to replace y with negative 5. And every time I write down negative 5, I need to make sure that I write it in a way that clearly communicates the operation that needs to be performed upon the negative 5. In the numerator, the first operation that I need to perform is 2 times negative 5. To really communicate that, I'm going to write the negative 5 in parentheses. In the second term, I'm subtracting or adding the opposite of 3y squared. Since I need to square a negative number, I know that that negative number needs to go inside parentheses. Likewise, in the first term of the denominator, I'm squaring a negative number, so the negative number's going inside parentheses. And finally, in the denominator, I'm subtracting 20. When I'm simplifying a fraction, the first thing I need to do is simplify the numerator and the denominator, and finally, after I've done that, I can perform the division. In the numerator, there's 2 terms. The 2 terms are ultimately separated by a subtraction sign. Subtraction is the last thing that occurs in order of operation, so the first thing I need to do is consider the expressions on either side of the subtraction sign. The expression to the left of the subtraction sign is 2 times negative 5. That's negative 10. The expression to the right of the subtraction sign has 2 operations. It has multiplication and it has a power. Powers are done before multiplication. So the first thing I need to do is square negative 5, which gives me positive 25, and I still need to multiply that by 3. So I have 3 times 25. In the denominator, I have a subtraction. That's the last thing I'm going to do. The first thing I need to do is simplify the expressions on either side of the subtraction. Negative 5 quantity squared is 25 minus 20 is already simplified. In the numerator, I have a multiplication that needs to be performed before I can do the subtraction. The first term is negative 10, and I'm adding to that the opposite of 3 times 25. I'm adding negative 75, which is the same as subtracting 75. In the denominator, I have 25 minus 20, which is 5. It's still too soon to do the fraction division. I still need to add negative 10 and negative 75 in the numerator. That's going to give me negative 85. That negative 85 needs to be divided by 5. And if I think real hard, I think I'll get the right thing here. 5 goes into negative 85 negative 17 times. So if y equals negative 5, the expression 2y minus 3y squared over y squared minus 20 evaluates to the number negative 17. Let's put this concept into a mathematical model. The mathematical model, m equals 200t over t squared plus 100, approximates the monthly revenue, that's what m is representing, measured in thousands of dollars, generated by sales of a new video game t months after its release. Let's use this formula to estimate the sales revenue 10 months after the game is released. Going back to our problem statement, we can see that t is representing the number of months since release. So if we want to know the monthly revenue 10 months after release, what we need to do is we need to evaluate the expression 200t over t squared plus 100 when t is 10. If t equals 10, then our monthly revenue which is represented by the letter M, is equal to 200t over t squared plus 100. And if t is 10, this expression is equal to the fraction whose numerator is 200 times 10 and whose denominator is 10 squared plus 100. So let's go ahead and simplify both the numerator and the denominator. In the numerator, all I have is 200 times 10, that's 2,000. In the denominator, I have a power and an addition. The power comes first. 10 squared is 100. So the denominator is 100 plus 100. My numerator I've already simplified to 2,000. The denominator completely simplifies to 200. And 200 goes into 2,000 10 times. So if t equals 10, m also equals 10. But I haven't yet really answered the question. The question asked me to estimate the sales revenue 10 months after the game is released. So far, all I've said is m equals 10. I haven't said what the sales revenue is 10 months after the game is released. Going back to my problem statement, m represents in thousands of dollars the monthly revenue. So if m is 10, we have 10 thousands of dollars, which we normally just remark as $10,000. So I'm going to go ahead and write my conclusion using a complete sentence. What we're going to say here is that 10 months after the video game's release, the monthly revenue generated by sales is about $10,000. The reason I threw the word about in there is because the problem statement did say that this formula would just approximate the monthly revenue. So I thought I'd go ahead and use an approximation kind of word, like about. So that's the conclusion of our lesson on expressions, simplifying expressions, and evaluating expressions.